Hello, in this video we're going to be talking about the Myelin sheaths, so let's not waste any of your time. Let's get right to it. Now when we're talking Myelin sheaths, what we want to recognize is that this is an insulation, kind of a barrier or wrap around the axon of certain neurons. You can think of it as like a cord, power cord for like a lamp or a tool or an extension cord. Inside it's got the metal wiring, and around it is a plastic coating, obviously for protection and safety. But the Myelin sheath can be thought of in that way. The Myelin sheath, as we've already mentioned, in the CNS, the oligodendrocytes make that, and in the PNS, it's the Schwann cells that do that. And you can see they're kind of made up of proteins and lipids, with 80% being the lipid portion. Now the process of making these Myelin sheaths around the axons is called myelination. It begins fairly quickly, fairly early in the fetus, as you can see there in the 14th weeks. That's roughly the end of the first trimester. Infancy development increases, and in somewhere late adolescence, which I'm interpreting as I don't think middle school, but maybe early high school, middle school, in there somewhere. Now when we're thinking Myelin, and you can see here it says that Myelin sheath is segmented, that doesn't refer to the fact that the Myelin sheath itself is in sections. It means that the production of Myelin sheath around the axon is done in segments. The nodes of Ranvier are the uncovered portion of the axon. There are little gaps in between, and it's the internodes that are the covered section. Of course, it begins right below the trigger zone, and we saw this back in talking about neurons. But that trigger zone is the spot on the soma, right at the bottom, as the axon begins. That's where the initial segment is. Now this process in the PNS is a little different than in the CNS, so you want to be sure you recognize which one this is. But this is done by the Schwann cells, and you can see that the Schwann cells just begin to kind of just move around, just like if you were wrapping, say, a towel around your arm. You would put the first part down, or plastic wrap, or whatever may be the case, and they would just go around and around and around. You can see in a clockwise fashion, just laying this sheet down, and then once it's in place, it's called Myelin sheath, but once you get all the layers down and it's just one continuous layer, that's called the neurolema. And when we talk about regeneration of nerve fibers, if there's a chance, if it's damaged and has the opportunity to get repaired, it's got to have that neurolema. At least some of it has to still be there. And then on top of that, just for protection and insulation and safety, the endorema, that's kind of a plastic coating on top of the plastic coating. So it'd be like if you had some sort of injury to your arm, and you wrap the plastic gauze around the injury, and then you put something around that, maybe a towel or something to keep it protected, even more so, or tape or whatever around that. That would be the enderema. Now, as we mentioned a couple times previously, in the CNS, that's the oligodendrocytes. Again, oligodendrocytes only, and so they will attach that, and it takes a lot of them, as it says there, working in tandem to get that sheet down. And you can see that the direction is the opposite. This is counterclockwise. And again, it just wraps it around, produces a sheet, wraps around it. It is not, Schwann cells makes a little different product. It's not neurolema, and there is no enderema to cover it. Now, these last two slides are going to talk about cells that are not, and then how that affects the speed of the signal. Now, the speed of the signal, we're going to use the term slower. It's not slow by any means. No, your reactions to things and information from the brain is incredibly fast. Just in some aspects, it's slower. But there are some cells in the CNS and the PNS that are unmyelinated. They don't have that wrapping, and you can see an example of that in that diagram to the left. You can see the dark bands around the neuron. That's the myelin sheath, and you can see the one below that doesn't have those dark bands. So that's unmyelinated. It means it does not have the myelin sheath. And how that affects the nerve fiber is the speed of the signal. Okay, there's two factors, but we'll start with the myelin sheath. If it has the myelin sheath, then the signal is faster. Okay, then if it doesn't have it, it is slower. And the other aspect that factors the speed is diameter. Okay, so a larger fiber is going to have more of a surface area and conduct the signal faster. So if you think about situations where it's going to have the fastest signal speed would be a large myelinated neuron or cell. If it is large and it's unmyelinated, then it will still be fast, but it will be slower. And then the slowest of the fast speeds is small unmyelinated fiber. So that's our video over the myelin sheaths. When we come back together next time, we're going to be talking about situations where there is a regeneration or repair of nerve fibers. We'll see you then.